Hello. Today we are going to talk about how to configure a port mirror on a Juniper router to capture transit MPLS traffic. So the diagram I have here explains what exactly is the scenario we are trying to test. So we have an ingress MPLS node that is putting in labels or pushing in labels for a traffic and sending it across to an egress node as shown in the diagram. Now on an MPLS transit node, sometimes you may want to capture those packets like a port mirror, including the layer 2 information and layer 2.5 information, in this case MPLS. So there are options in Juniper router to do that quite easily. One option that I'm demonstrating here is to mirror that packet and send it across an L2 circuit to a terminating node where the L2 circuit finishes, and those packets are eventually sent out to an Ixia where we will be capturing them. So this is just the flow. I will quickly show the configurations that is required. There is no configurations required on the ingress and egress node. They just continue to operate normally. What we really need is a configuration on the MPLS transit node for port mirroring, and we push the traffic into an LT interface, that is a logical tunnel interface, just to push it via the L2 circuit. So quickly going into the configurations. So this is the box, this is the transit node. I will just show you the configurations. So first we define an LT interface, which is a logical tunnel interface. And what we do here is we create two units inside the LT interface. Unit 3 is the MPLR port mirroring interface, just a description. The key part here is encapsulation Ethernet bridge, and the peer unit points to the adjacent LT interface. It is like a logical stitching. And the family defined here is family bridge. And for unit 4, you can see the peer unit is pointing to peer 3, the unit 3. So they are just like back to back interfaces. We are creating a logical link between them. And the key part here is for unit 4, it has encapsulation Ethernet CCC. And we can use a firewall filter on the family CCC if you want to send the traffic on a high priority class of service queue. But that is not something really required here. What is key point here is just look at the peer unit mappings between the unit 3 and unit 4, and the encapsulation that is given on unit 3, which is encapsulation Ethernet bridge, and the interface that is a part of L2 circuit to be encapsulation Ethernet CCC. The next things we do is under forwarding options on this MPLS transit node, we enable a sampling rate of 1. Obviously rate 1 is quite high. In your scenario, you may be doing 1000 as a rate, which is normally the recommended value. Just for demonstration, I'm using a rate of 1. The key part for MPLS port mirroring is the family any is the output, and I'm pointing it to a next stop group, because when you do MPLS mirroring, you also want to capture the layer 2 information as it is. So in order to achieve that, you have to create a next stop group, and I'm calling it a name. Now what is exactly inside the next stop group is defined here. So you call the group type as layer 2. So I want the mirroring to happen at the layer 2 level itself, and I'm pointing it to the outbound interface. So whatever is being mirrored is pushed into LT1100.3. Now because LT1100.3 is pointing to LT1100.4, so this packet will reach 4, and 4 will take it up via L2 circuit as explained in the diagram and send it off to the remote location where it can be collected. Now the L2 circuit configuration is quite simple. I'm pointing to the remote node of my L2 circuit. As we discussed, LT11004 is the interface that is receiving the mirrored traffic from 3, and we are just forwarding it to the remote end with encapsulation Ethernet. Now checking the forwarding options port mirroring, you can see that the interface of family any state is up. Usually this should be up. If it is down, then you know that your port mirroring configuration is wrong. Also verifying the show L2 circuit connections, you can see my L2 circuit is up. Now the next key part is we have in the diagram, as we mentioned, a point where we mirror the traffic, right? So first we create a forwarding options family MPLS filter, and we define an input filter. So across any interfaces on the input point on this MPLS transit node, there is an MPLS filter that is referenced. And the MPLS filter is defined here, where we call term 1 from IP version. So for family MPLS filters, now you have the feature of defining what version of traffic that you want the filter to act upon. So in this case, the MPLS filter should look for IP version IPv4 and look for anything with source address of this address 109.1, then mirror it. Whatever remaining, they should be accepted. So what this will do is it will mirror and send all these traffic via L2 circuit to the terminating L2 circuit node. On the terminating L2 circuit node, it's the same story. We have a protocol L2 circuit. Here we point to the MPLS transit node as the neighbor, the outgoing interface where the mirror traffic will be sent out towards a collector. In this case, I'm using an Ixia. In your case, you can even have a PC. Apart from that, the interface on the terminating node of L2 circuit just has Ethernet CCC as an encapsulation, no other fancy stuff, and you can see that the L2 circuit is up. Now, when the mirroring is working fine, as we can check, so I am just going to check monitor interface LT 1100.3. I know the mirroring has to be sent out of 1100.3. So you can see that the packets, when they're running, they should go out of this interface. Normally there will be packets. I've already sent 1359 packets here. So we can just check the result on the collected Ixia packets here. And here you can see that we have the mirrored packet with all the source addresses of 109.1 and MPLS headers are all captured with their IP addresses. So I wanted to also highlight that when we are configuring the port mirroring, the LT interface unit 3 has to be a part of the bridge domain to complete the whole configuration. So LT interface unit 4 is a part of L2 circuit, as I had explained earlier, but LT interface 00.3, which is where the port mirroring traffic is sent out, it has to be a part of bridge domain as shown here.